The foreman's translator rendered the laughter before the words caught up. Das Kivari stood at the base of column 9 with a data slate in one claw and an expression that, on Avrelian, meant something between pity and entertainment. His crystalline hide caught the arc lamp light and threw it across the staging platform in fractured rainbows, little prismatic ghosts that danced on the grating whenever he shifted his weight. Behind him, 14 Vrelian riggers leaned on their grav hoists and watched the new assignment with the lazy attention of men who had just been handed a show. Nate Dallow set his kit bag on the platform grating and looked up. Column 9 rose 400 meters into the interior void of the Morenthi span, the largest orbital bridge segment under construction in the compact. It was an open lattice compression pillar, half-built, its upper sections trailing cable anchors into nothing. Even from the base, Nate could see where the work had stalled. The alignment was off by at least 2 degrees. The cross-bracing looked improvised. 3 of the lateral nodes were shimmed with what appeared to be packing foam. Human structural engineer, Kivari read from the slate, his tone the flat, deliberate cadence of someone reading a joke setup. Assigned to manual labor detail, exterior column division. He looked up. You understand what manual labor means here. Moving things, Nate said. Moving things that weigh more than your species. Kivari's facets rippled, which was the Vrelian equivalent of a grin. The riggers behind him made low grinding sounds, their laughter rolling through the platform like stones in a tumbler. We requested a cargo mover. They sent a man who draws lines on paper. I also erase them sometimes, Nate said. Nobody translated that. The joke hit air and died there, which suited Nate fine. He hadn't been expecting an audience. Kivari tapped the slate and brought up the day's manifest. Column 9, upper node replacement, sections 41 through 48. The brackets need to be removed, reseated, and torqued. The alignment cradle hasn't been calibrated since last quarter. The previous detail quit. The detail before that requested transfer. He paused. The detail before that is still on medical leave. What happened to them? Gravity shear. The stabilizers on the upper sections cut out when you cross the 300-meter line. The span's tidal envelope runs transverse to the column axis up there, so anything not clamped down drifts, including workers. Kivari's facets went flat, the serious expression, the one that looked like someone had polished the comedy right out of his hide. You are not equipped for that environment. Your species lacks anchor points. You have no carapace. Your grip strength is, he consulted the slate, classified as adequate for light assembly. This is not light assembly. Understood. You'll work the lower sections, hauling, sorting. Bracket transport from the fabrication floor to the staging rack. Nothing above 50 meters. Nate looked at the column again. The misalignment was worse than 2 degrees, closer to 3. The shimming on the lateral nodes was going to transfer load unevenly once the upper sections went under compression. Whoever had set them hadn't accounted for the crystalline expansion coefficient of Vrelian ceralloy under thermal cycling. He'd read the material specs on the shuttle in. Sure, he said. He didn't elaborate. There was nothing to elaborate on. Kivari had given him an assignment. The assignment was bracket hauling. Nate would haul brackets. The fact that he could see 6 structural defects from where he was standing didn't change the assignment. It just meant he'd have something to think about while he hauled. Kivari assigned him a position number, a magnetic tether, and a slot in the rack room. The tether was designed for Vrelian anatomy, a hip-mounted clamp system that assumed the wearer had a lower torso with 4 anchor ridges and a center of mass about 20 centimeters lower than Nate's. He clipped it to his belt, cinched it with a half hitch from the excess strap, and let it ride. The riggers watched him walk to the bracket transport station. One of them, a big one, facets the color of smoked quartz, arms like stone columns, said something that the translator rendered as, "I give him 4 hours. Generous, another one said. The brackets weighed 90 kilos each. There were 60 of them stacked in the fabrication bay, still warm from the presses. Each one a seroloid channel section designed to slot into the column face and distribute compression load across the lattice. The staging rack was 200 meters along the gantry, connected by a rail system that hadn't been serviced in weeks. The rail car was jammed at the far end with its brake calipers fused. Nate looked at the rail car, looked at the brackets, looked at the 200 meters of open gantry between them. He picked up 2 brackets, one under each arm, pressed them against his ribs, and started walking. The first trip took 11 minutes. The gantry walkway hummed under his boots. He set the brackets on the staging rack, straightened his back, and walked back. The second trip took 9 minutes. He'd found his rhythm, a steady, unhurried pace that let him breathe through the load without burning out his legs. On a construction site in Albuquerque, he'd once carried 60-pound bags of concrete mix a quarter-mile uphill because the mixer had broken down and the poor window was closing. His foreman had called it stupid. Nate had called it Thursday. By the 4th trip, the smoke quartz rigger had stopped talking. By the 8th trip, Kivari had come out of the site office to watch, his facets doing that slow lateral shift that Nate would later learn meant recalculation. By the 12th, someone had pulled up the shift clock on the overhead display and started timing him. Nate didn't notice. He was counting brackets and thinking about the shimming on section 43. The foam was going to be a problem. He could see it from the gantry walkway, pale yellow material wedged into the node joints, compressed and slightly discolored from thermal cycling. The kind of thing that looked like a solution and was actually a timer. Every thermal cycle would compress it a little more. Every compression would shift the load path a little further from where the designers had intended it. Packing foam was rated for cargo holds, not compression pillars. Someone had grabbed the nearest soft material and jammed it into the gap because the seroloid inserts were back-ordered, and nobody had come back to fix it because nobody was checking. He filed that under later and kept carrying. He finished all 60 brackets in 4 hours and 6 minutes. The shift was 8 hours. He had the entire staging rack loaded, sorted by size, and arranged in installation sequence before the mid-shift break a word that implied rest, though Nate used it to walk the base of column 9 with his hands in his pockets, studying the lattice geometry from ground level. Kivari came down to the staging rack and looked at the arrangement. The brackets were organized not by Vrelian standard inventory order, which went by fabrication lot number, but by structural position, with the load-bearing primaries at the front and the secondary stiffeners grouped by the column section they served. "Who told you the installation sequence?" Kivari asked. "Nobody. It's a compression pillar. The primaries go in first, or the secondaries bind." Kivari stared at him. His facets did that slow lateral shift again, mineral surface examined under a different angle of light, discovering something it hadn't expected. "Finish your break," Kivari said and walked away. The second half of the shift was reseating brackets on sections 12 through 16, the low sections, the safe ones, the ones that didn't require crossing the gravity shear line. The Vrelian crew worked in teams of 4, one on the grav hoist, one on the torque driver, 2 spotting. The brackets slotted into channel grooves in the column face and were torqued to a specification that, according to the manual, required a calibrated Vrelian torque driver with species-specific grip feedback. Nate didn't have a calibrated Vrelian torque driver. He had a socket wrench from his kit bag and 23 years of feeling when a bolt was seated right. He asked the spotter on section 14 if he could try one. The spotter, a pale blue Vrelian with young, bright facets and the cautious energy of someone in their first year on a real job, looked at Kivari. Kivari looked at Nate. Then he waved one claw in a gesture that translated roughly as "proceed at your own professional risk." Nate climbed the scaffolding to section 14, set the bracket, ran the bolts down by hand until they stopped, feeling the thread seep through his palm, then the socket wrench. Leaning his weight into each one, steady, patient, feeling the metal settle against the channel the way you feel a handshake tighten not by measuring, but by knowing 4 bolts, 6 seconds each, the bracket didn't move. The pale blue spotter, his name was Tessari. Nate would learn ran a torque check with the calibrated driver. The reading came back within 0.5% of specification. Nobody said anything. Nate climbed down and asked for the next one. By the end of the first day, he'd reseated 11 brackets. The Vrelian teams had done 9 each, working in groups of 4. The difference in labor efficiency was large enough to show up on the shift log as an anomaly. Kivari flagged it for the site superintendent's review, then stood at the office window for a while, looking at the staging rack, looking at the brackets arranged in an order he hadn't seen before. Nate went back to the rack room, ate a ration bar, drank water from a steel bottle that weighed nothing compared to the day, and pulled up the engineering drawings for column 9 on his personal tablet. He worked through them the way he worked through everything, methodically, patiently, without any expectation that the answers would be easy. The misalignment wasn't just bad, it was structural. The entire upper lattice was torquing under its own weight because the base nodes had been installed with a rotational offset. Someone had eyeballed the alignment instead of using the laser frame, and every section built on top of that error had compounded it. 3 degrees at the base became 6 at mid-height. 6 became critical at the top. He made notes, then he slept. The second day, Kivari was waiting for him at the staging platform with the morning manifest, and a reluctance Nate could read from 20 meters away. Section 22 through 28, same work, bracket reseat, a pause, you'll have a spotter. The ones on 22 are shimmed, Nate said. Kivari's facets tightened the defensive reflex, the mineral equivalent of squaring your shoulders. The shims are approved. They're packing foam. They're thermal expansion compensators. They're packing foam rated for cargo holds, not compression pillars. The thermal cycling up here runs 70 degrees wider than the rated range. Those shims are going to compress to nothing inside 2 cycles. Then the load path shifts and the node transfers stress to the adjacent brackets, and you get a cascading misalignment on top of the rotational offset you've already got at the base. The platform went quiet. 3 riggers who had been pretending not to listen stopped pretending. Gorund, the smoked quartz one, set down the bracket he was holding and looked at Nate the way you look at a tool that just cut through something it shouldn't have been able to cut. Kivari set his data slate against his thigh. And you know this because you draw lines on paper. I know this because I read the material data sheet. It was in the project file, page 16. The data sheet was, in fact, on page 16. Kivari checked. The silence on the platform got louder. Remove the shims, Kivari said to the crew. Replace with Saralloy inserts from stock. He didn't say anything else to Nate, but the dynamic had changed. Nate could feel it the way you feel weather turning, not in any single indicator, but in the overall pressure of the room. Tessari, the young spotter, started asking questions, not skeptical questions, curious ones. What was the expansion coefficient of Saralloy? How did Nate calculate load paths without a Vrelian structural modeler? What were the lines he was drawing on his tablet during breaks? Influence diagrams, Nate said. They show where the load goes when something changes. We have computation arrays for that. I know, but the computation array needs correct input data, and your base node alignment is 3 degrees off, so everything the array calculated for the upper sections is wrong. It's computing perfect answers to the wrong question. Tessari's facets went very still, 3 degrees. 2.7. I measured it this morning with a plumb line and a piece of string. A piece of string. And a plumb line. The plumb line was a socket wrench on the end of the string. Tessari went to find Kivari. Kivari went to find the site superintendent. That afternoon, the site superintendent, a massive Vrelian named Archoverseer Drekken, with facets like black granite and the demeanor of someone who had built things longer than Nate's species had been building in space, came down to column 9. He brought 2 survey engineers with laser frames. They measured the base nodes. 2.8 degrees of rotational offset. Nate had been off by 1/10 of a degree with string and a socket wrench. Drekken looked at the laser frame readings, then at Nate, then at the socket wrench hanging from a lanyard on Nate's belt, still swaying slightly from the walkover. "This is the human," Drekken said to Kivari. "Not a question, a confirmation of something he was deciding how to process. This is the human. And he found this with string. And a socket wrench," Kivari said. His voice had a quality Nate recognized from every construction site he'd ever worked, the sound of someone who'd been telling a joke for 3 days and had just realized the punchline was on him. Drekken ordered column 9's upper section stripped back to the base nodes. 3-week setback. The foreman who'd originally set the base nodes was reassigned. The site engineers who'd signed off on the alignment were put on review. The correction work needed someone who could calculate compensating offsets by hand, because the computation arrays model was built on the wrong baseline, and reprogramming it would take longer than doing the math on paper. Kivari offered the work to his survey team. They declined. It required working above the 300-meter gravity shear line, in transverse tidal forces that made precision instruments drift and Vrelian workers cling to their tethers like barnacles on a hull. Nate volunteered. "You're not certified for shear line work," Kivari said, in the voice of a man looking for a reason to say no and not finding one that held. "The shear is 0.3 G transverse. My species operates in full G longitudinal as a baseline. I'll drift less than your riggers." Kivari checked the specifications. Human baseline gravity tolerance, 1 G sustained. Transverse tolerance, a footnote most compact certifiers had never read because no human had ever been assigned to a project where it mattered. "I'm not approving this," Kivari said. Drekken approved it. Nate went up. The gravity shear hit at the 300-meter mark like stepping into a river current, a steady lateral pull that wanted to slide him sideways off the scaffolding and into 400 meters of open void. He leaned into it the way you lean into wind on a rooftop, set his mag boots to maximum, and started working. He had a transit level he'd jury-rigged from a laser pointer, a mirror and a bracket clamp, a grease pencil for calculations, his socket wrench, his hands. The first node took him 2 hours, measure the offset, calculate the compensating rotation on the column face in grease pencil, pull the alignment pins, rotate the node, reseat the pins, run a plumb check, move on. "Dead center." Tessari's voice came through the comm from far below, thin with distance and something else. "Alignment reading on node 41. 0.03 degrees. That's within half the specification tolerance." "Is that good?" Nate asked, adjusting his grip on the scaffolding rail while the transverse pull tugged at his hips like a patient child. "That's better than our original installation, by a significant margin." "Good," moving to 42. Down on the platform, the entire column 9 crew had stopped working to watch. Goran sat on a stack of brackets, massive arms folded, his smoke quartz facets tilted upward at the tiny human figure 400 meters above him, scratching numbers on a column face with a waxy stick. Goran had been building structures his entire working life. He'd never seen anyone do what the human was doing, not because it was impossible, but because nobody had ever considered it worth trying. The shear zone was where you sent drones. You certainly didn't send a man armed with mirrors and string. The second node took 1 hour and 40 minutes. The third, 1 hour and 12. Nate was developing a system, each step stripped to its essentials. No wasted motion. The rhythm of it building the way rhythm always builds when you do something enough times that your body starts finishing the sentence your mind started. Within tolerance, Tesori called up. Within tolerance. Within tolerance. He's tighter than the original specification, Tesori said after the fifth node, his voice carrying a quality the translator couldn't quite parse, halfway between professional admiration and the slow dissolution of a worldview. He's not just correcting the error, he's improving on the design. Kivari, standing beside Tesori on the platform, didn't comment. He was looking at the numbers. The numbers were doing the talking for him, and they were saying things his 1,200-year engineering tradition hadn't taught him to expect. Nate finished all 8 upper nodes in 3 days. The project timeline had allocated 3 weeks. The survey team confirmed every node within specification. 4 of the 8 exceeded the original design tolerance by margins that prompted a quiet memo from the engineering review board, asking what instrument the human had used for alignment. The answer, a laser pointer, a mirror, a bracket clamp, and a grease pencil, was included in Tesori's supplementary notes, where it sat with the particular dignity of a fact that nobody wanted to explain at a meeting. Tesori also filed a personal observation. The human's instrumentation budget for this task was approximately 0. His accuracy exceeded that of our calibrated laser frame system. I do not have an explanation for this and have stopped looking for one. Drekken came down to column 9 on the day the correction work was verified. He stood at the base of 400 meters of perfectly aligned compression lattice and looked up at it the way you look at something you'd been told was impossible and are now standing underneath. "What else is wrong with my project?" he asked Nate. Nate pulled out his tablet. He had a list. He'd been compiling it since day 1, adding to it during breaks, during walks through the lower gallery after hours, during the long, quiet evenings in his rack room bunk when the station hummed around him, and every hum told a story. Column 14 had a resonance harmonic in its cross-bracing that would amplify under traffic loading. Columns 3 and 7 shared a foundation plate with a hairline crack that nobody had caught because the inspection protocol tested for Vrelian spectrum fractures, not the lower frequencies that a human ear could pick up by tapping the plate with a knuckle. The main span cable anchors on the western approach had been tensioned to compact standard, which assumed a stable orbit, and didn't account for this station's processing binary orbit introducing a cyclic lateral load every 41 hours. And the fabrication bay was producing brackets with a burr on the inner channel face that was reducing torque contact by approximately 11%. Drekken listened to the entire list without interrupting. His black granite facets shifted through configurations Nate couldn't read, but the silence was eloquent enough. "How long have you been here?" Drekken asked. 12 days. "And you found all of this in 12 days. "I found most of it in the first 4. The rest I confirmed as I worked." Drekken turned to Kivari. What was his original assignment? "Bracket hauling," Kivari said. The words came out flat, stripped of anything that might have been mistaken for comedy. Bracket hauling. He was sent as a manual laborer. His transfer file listed structural engineering credentials, but the intake system categorized them as non-equivalent. Non-equivalent to what? To Vrelian certification. His string found what our survey team missed. Kivari said nothing. That was its own answer. Drekken reassigned Nate from manual labor detail to engineering oversight column division. 3 forms, 2 departmental approvals, and a species capability assessment that had never been performed for a human, because no human had ever been assigned to the Morenthi span before. Tesori conducted the assessment. By this point, he'd stopped asking questions about Nate's methods and started taking notes the way a student takes notes when they realize the teacher isn't who they thought. Structural analysis hand calculation, verified. Alignment correction field conditions, verified, exceeds specification. Load path diagnosis novel methodology. He looked at Nate's influence diagrams. "I don't have a checkbox for this." "Put verified," Nate said. "What's the methodology called?" "Statics." Tessari entered it as Human Proprietary Analytical Method Statics and moved on. The reassignment didn't change the work. It changed the paperwork around the work. Nate still showed up at the same time, still carried his kit bag, still wore the Vrelian tether clipped to his belt with the excess strap dangling because nobody had manufactured a human-sized replacement, and Nate hadn't asked for one. The difference was that now, instead of being assigned tasks from Kivari's daily manifest, he was expected to identify his own. He started with the items on his list. The bracket burr issue was first because it was the fastest to fix and the most widespread. He walked into the fabrication bay, found the shift supervisor, a heavy-set Vrelian whose facets were the dull amber of someone who had been running presses for 30 years, and had heard every suggestion a visitor could offer, and asked to see the die. "The die is certified," the supervisor said. "I'm not questioning the certification. I'm questioning the exit stroke." "The exit stroke is part of the certification." "Then the certification doesn't account for channel face contact area." The supervisor's amber facets darkened. He drew breath for the speech, the one about experience, about years on this project and projects before it, about the particular inadequacy of humans attempting to advise Vrelians on Vrelian manufacturing. Nate took a bracket from the output rack, ran his thumbnail along the inner channel face, and held it up to the bay light. The burr caught a thin, raised line of cerulloy, running the full length of the channel, barely visible to crystalline eyes that were optimized for structural geometry rather than surface finish. "That's within tolerance," the supervisor said, but his voice had changed. "Dimensional tolerance, not functional tolerance. This lip reduces the contact area where the bracket seats into the channel groove, which means the torque is being transferred through a smaller surface, which means the effective clamping force is 11% lower than design." Nate set the bracket on the workbench. "If you chamfer the die exit by 0.5 millimeter, the burr won't form. The brackets will seat flush." 0.5 millimeter. "I can mark it for you." The calculation happened behind the supervisor's amber facets, pried against the quiet, inescapable arithmetic of a defect that 9 months of production hadn't caught, identified by a man who'd run his thumbnail along a piece of metal and known. "Mark it," the supervisor said. Nate marked it. The die was modified. The next batch came out clean. Goran brought Nate one of the new brackets that afternoon, turning it over in his massive claws with the deliberate care of someone who worked with his hands and knew the difference between right and almost right. "It feels different," he said. "It seats better." Goran looked at the bracket the way a man looks at a tool that's been lying to him for 9 months. "I've been hauling these the whole project. They always felt wrong. I thought it was me." "It wasn't you." Goran set the bracket on the staging rack carefully, the way you set something down when you've learned it deserves more respect than you've been giving it. Then he walked away without another word. It was, Nate understood, the Vrelian equivalent of a handshake from a man who communicated primarily through the amount of weight he could carry. The resonance harmonic on column 14 was next, and it was the one that kept Nate awake. Not because it was complex, because it was invisible. The other problems, the misalignment, the shimming, the bracket burrs, were things done wrong, mistakes, human errors or Vrelian errors, but errors nonetheless. Column 14 was different. Column 14 was built correctly by the book to specification, every bracket seated, every bolt torqued, every node aligned within tolerance, and it was going to tear itself apart. Nate found the harmonic on a night walk through the lower gallery. He developed the habit of walking the structure after hours, when the fabrication bay shut down and the ambient noise dropped to the deep, subsonic hum of a station at rest. In the silence, the structure talked. Every piece of steel or cerulloy in this case had a voice. a frequency, a way of telling you whether it was carrying its load happily or holding a grudge. You just had to know how to listen. Column 14 wasn't happy. He felt it through his boots first, a pulse, rhythmic every 41 seconds, not the steady hum of static loading. A beat. He stopped, stood still, and timed it against his watch. Then he pulled up the station's transit schedule on his tablet and overlaid the timing. Perfect match. Main transit carriages crossing the span's upper deck ran on a 41-second interval during peak hours. Every crossing sent a vibration through the deck structure, through the support columns, into column 14's cross-bracing. And the column's natural frequency was almost exactly 41 seconds. Not a coincidence, a resonance. The amplitude was growing. Slowly, invisibly, the way a crack grows imperceptible until the day it isn't. On Earth, every first-year engineering student learned about this. The textbooks had photographs. There was even film footage, 86 years old by the time humans discovered faster-than-light travel, of a bridge called Tacoma Narrows tearing itself apart in a 40-mile-an-hour wind, not because the wind was strong, but because the wind's frequency matched the bridge's frequency, and the structure had amplified itself to pieces. The Vrelians had never had that lesson. Their crystalline materials were strong enormously, spectacularly strong, but they shattered catastrophically instead of bending. They didn't creak. They didn't sway. They didn't give warnings. They held, and then they didn't. The entire Vrelian engineering tradition was built on preventing failure through computation, because by the time you could observe a Vrelian structural failure, it was already complete. Humans built with steel. Steel bent. Steel creaked. Steel told you it was unhappy long before it quit. And humans had spent their entire engineering history listening to those warnings, developing an intuition for wrongness that no computation array could replicate because it lived in the body, not the math. Nate redesigned the cross-bracing on column 14 using a tuned damper pattern, 6% more material, different geometry, enough to shift the column's natural frequency away from the traffic harmonic and break the resonance. He drew it on his tablet and showed it to Tessari. "This is simple," Tessari said, after staring at the drawing for a long time. "That's the idea. We spent 6 weeks computing harmonic responses with our modeling array. Your solution is geometry. Geometry is what structures are." The fix went in. The harmonic disappeared. Column 14 went quiet, the right kind of quiet, the kind that meant the metal was carrying its load without complaint. The computation team requested Nate's drawings. He sent them. They requested his computation notes. He sent those too, half a page of arithmetic, a free body diagram, and a sketch of a bridge that had collapsed on Earth 86 years before his species had discovered FTL travel. The computation team lead, a Vrelian named Sarath, came to column 9 to ask Nate how a species with 86 years of pre-spaceflight engineering history had developed a vibration damping technique that the compact's 1,200-year structural code didn't include. "We had a lot of bridges fall down," Nate said. "How many?" Nate thought about it, enough to learn. Sarath processed this. 1,200 years of Vrelian engineering knowledge, refined through computational models of extraordinary sophistication, and the answer to a gap in their code had come from a species that learned structural dynamics by watching their structures kill people. Because they'd had to. Because their materials forgave mistakes just long enough for someone to notice, and the ones who noticed had written it down. "Your species learns by failure," Sarath said. "Every species does. We just had more of it." Sarath was quiet for a while. Then he said something the translator struggled with, a Vrelian phrase that came through as the advantage of being breakable. Steel bent. Ceraloid didn't. And in the space between bending and shattering, humans had built an entire tradition of listening to what their structures were trying to tell them. The foundation plate crack on columns 3 and 7 was next. Nate found it the same way he found everything, by walking the structure at night and listening. He tapped the foundation plate with his knuckle, the way he'd been tapping concrete and steel since his first job out of school, crawling under highway overpasses in New Mexico with a hammer and a clipboard. The plate rang wrong. A clean plate resonated evenly, a sustained tone that faded smoothly. This one had a dead spot, a frequency gap where the energy was being swallowed by a discontinuity in the material. He marked it with his grease pencil and reported it to Kivari, who called the inspection team. The Vrelian inspectors brought calibrated scanning equipment, top of the line, 1,200 years of refinement equipment, designed to detect every known failure mode in crystalline ceralloy. They scanned the marked spot. Nothing. They scanned it again. Nothing. The lead inspector, a veteran named Haravan, 40 years on the job, 6 major projects, a man whose professional reputation was literally built on finding defects, looked at Nate with the carefully neutral expression of someone trying very hard not to say, "I told you so." "My equipment shows nothing," Haravan said. "Your scan frequency is optimized for crystal plane fractures," Nate said. "This is a grain boundary fracture, the interface between two crystal orientations. Different failure mode, different frequency. Your scan passes right through it. You're suggesting a fracture that our standard equipment cannot detect. I'm suggesting you try a different frequency." Haravan adjusted his equipment, scanned again. The crack appeared on the display like a shadow coming into focus 17 centimeters below the surface, propagating along a crystal grain boundary that no standard Vrelian inspection protocol had ever been designed to find. Because the failure mode didn't exist in their engineering tradition. Because their materials didn't fail that way until they did. Haravan looked at the scan, looked at the grease pencil mark, looked at Nate's knuckle. "You found this by tapping it." "My knuckle sends a broad-spectrum impulse. The fracture absorbs certain frequencies. I hear the gap." Nate paused. "I've been doing this since I was 22. You learn what wrong sounds like." Haravan was quiet for a long time. Nate recognized the expression on his face, or the facet configuration that served the same purpose. It was the look of a professional who had just discovered a blind spot in his own expertise and was deciding how to carry it. "I'd like to understand your method," Haravan said, "if you have time." "I have time." They spent an hour together that evening. Nate taught Haravan how to tap and listen. Haravan's claws produced a different impact spectrum, harder, sharper, but the principle was the same. You hit the plate. You listened. You learned what good sounded like. Then you noticed when it wasn't. By the end of the hour, Haravan had found 2 more spots. Nate confirmed both: 1 grain boundary anomaly, 1 bolt pocket with incomplete fill. 3 defects in 1 plate, invisible to 1,200 years of scanning technology, found by 2 men with their knuckles. "This is what you do," Haravan said. "This is what everyone used to do, before computers made us think we didn't need to." The plate was replaced. Columns 3 and 7 were re-leveled. The schedule absorbed another week, which was better than absorbing a foundation failure under full span loading. The cable anchor tensioning on the western approach was the last major correction, and the one that almost didn't happen. The western approach was managed by a senior engineer named Drast, an old Vrelian with battle-darkened facets, and a reputation for precision that bordered on religious conviction. Drast's cables were tensioned to compact standard. His section had passed every review. He did not appreciate advice from the column division, and he particularly did not appreciate advice from a human who had been on the project for less than a month. "The cables are tensioned to specification," Drast said, his voice carrying the weight of 40 years of never being wrong. "The specification assumes a stable orbit," Nate said. "This station processes around a binary system. You've got a cyclic lateral load on a 41-hour period that your tension values don't account for. The monitoring system has flagged nothing. The drift is below the threshold. It won't be in 6 months. Drast filed a formal rebuttal. Nate filed a formal concern. Both documents landed on Drecken's desk. Drecken ran his own analysis, re-examined the monitoring data with the precession cycle overlaid, and found exactly the trend Nate had predicted: a slow sinusoidal drift, currently below warning threshold, but on a trajectory that would cross critical in 7 months. Drast was given the data. He checked it 3 times because his entire career had been built on precision, and the numbers were telling him his precision had missed something fundamental. Then he came to column 9. Engineer Dallow, your concern was valid. I know. I need your tension specifications. Nate climbed down from the scaffolding, pulled out his notebook, and handed over 3 pages of hand calculations. Fourier decomposition of the cyclic loading, compensating tension values for each cable group, all of it done with a calculator, a notebook, and a pencil he kept sharpening with his pocket knife, because the Vrelian styluses were too thin for his fingers. Drast looked at the calculations for a long time. His facets cycled through configurations that Tessari, watching from the staging rack, later described in his notes as the slow collapse of a certainty. These are hand calculations, Drast said, for a cyclic orbital loading problem. Yes. A computation array would take 17 hours. I did it in 3 nights. The pencil is slower than a processor, but I don't have to program it. Drast made a sound the translator didn't render, the Vrelian equivalent of acknowledging something you'd rather not have learned. The recognition that 1,200 years of engineering tradition had a blind spot, and a man with a pencil had found it. I'll have my team retention to these values by end of week, Drast said, and left. He didn't say thank you. The fact that he'd come to column 9 in person in front of Nate's crew was the thank you. The cables were retentioned, the drift flattened to 0. By the end of the 3rd month, every active column on the Morenthi span had been touched. Not all by Nate personally. He couldn't be everywhere, but his influence diagrams, his corrections, his cross-bracing patterns, and his habit of finding defects by walking up to structures and hitting them had spread through the engineering team like weather changing. Workers started bringing him pieces. A welder on column 11 brought a joint that didn't look right. Nate ran his finger along the bead and found a gas inclusion. A rigger brought a casting that sounded wrong. Nate tapped it and identified a void. Goran brought brackets that didn't feel right, and Nate could tell in 3 seconds whether they were fine or needed to go back. It became an unofficial inspection layer. Fabrication, quality control, Goran, Nate's hands. 3 days after the cable fix, a new line appeared in the Morenthi Span's Quality Procedures Manual, Supplementary Tactile Inspection Manual, approved for all critical path components. The authoring engineer was listed as K. Kivari. He didn't mention Nate. He didn't need to. Drecken called a project review meeting. The main briefing theater on the administrative level, a curved amphitheater built for Vrelian anatomy, crystalline seats catching the light so the room looked like the inside of a geode. Every foreman, every team lead, every senior engineer. 83 Vrelians and 1 human. Nate sat in the back. The seats didn't fit him. He perched on the edge of one, boots on the floor, tablet on his knee. Drecken put up a single display. The structural integrity trend for the Morenthi span, plotted over 90 days. The line started flat, dipped where the column 9 misalignment had been accumulating stress, spiked where the foundation crack had been propagating, showed a slow oscillation from the cable drift, and then at the 60-day mark everything straightened. The line went flat, then better than flat, above the original design baseline. I called this meeting, Drecken said, because in 1,200 years of compact structural engineering I have never seen a project trend line improve during construction. They degrade, They hold. They degrade faster. They do not improve. He paused. Ours improved. And the reason is sitting in the back row, trying not to be noticed. 83 pairs of crystalline facets turned toward Nate. He looked up from his tablet. I was reviewing the drainage specs for the service galleries. You've got a condensation issue on level 8. The room didn't laugh. Not because it wasn't funny, it was, in the quiet, recognizable way of a man responding to institutional recognition by pointing at a dripping pipe, but because the room was still catching up. Drekken let the silence hold. The human was assigned to us as a manual laborer. His credentials were classified as non-equivalent. He was given bracket hauling because we didn't know what else to do with him. Another pause. He has, in 72 days, identified and corrected defects that our survey teams, our modeling arrays, and our 1200-year structural code did not detect. He has done this with hand tools, hand calculations, and an analytical tradition that his species developed because their bridges kept falling down. Someone in the middle rows made a sound that might have been a laugh. I am recommending that his credentials be reclassified. I'm also recommending that his methodology, which his species calls statics, and which appears to consist primarily of looking at things, hitting them, and listening to what they say, be reviewed for incorporation into the compact structural code. Dras spoke from the third row. His voice was flat, precise, the voice of a man applying his precision to something harder than cable tension. For the record, the cable drift on the western approach was identified by Engineer Dallow 63 days before our monitoring system would have flagged it. His hand calculations matched my section's full reanalysis to within 0.2%. My initial rebuttal was based on procedural grounds that, in retrospect, prioritized protocol over physics. A pause. I am withdrawing the rebuttal. In 1,200 years of compact engineering review meetings, a senior section engineer had never publicly withdrawn a rebuttal. The room absorbed it the way the structure absorbed load, silently, under pressure, with the slow recognition that something had permanently changed. Drekken turned to Nate. Do you have anything to add, Engineer Dallow? Nate looked at his tablet. He'd been reviewing the drainage specs during the last 15 minutes of the presentation, because the trendline data wasn't new to him and there was work to do. The condensation on level 8 is going to corrode the junction plates if you don't fix the vapor barrier. I can draw you a fix tonight. 20 minutes of work. Sareth, the computation team lead, made a small sound from the fourth row. A laugh. Brief, quiet, the kind that comes from recognition rather than amusement. Drekken's black granite facets shifted into a configuration that Tessari later told Nate was profound. Unwilling respect, the kind that arrived not because you wanted to give it, but because the evidence left you no choice. Draw the fix, Drekken said. The meeting ended. The riggers filed out in a silence that was different from the one they'd brought in. Gorand paused at the amphitheater door, looked back at Nate, and tapped the doorframe with his knuckle. Once, twice. The sound test. The tap-in listen. Gorand was telling him in a language that didn't need a translator that the sound was good. The structure was solid. Nate tapped back. Gorand's smoke quartz facets caught the light. He walked out. Kivari found Nate in the corridor afterward, still on his tablet. Engineer Dallow. Nate looked up. First time Kivari had used the word engineer. When they sent you to us, I submitted a formal objection. I told Intake that assigning a human to an orbital megaproject was a resource waste and a safety liability. I read the objection. It was in my transfer file. Kivari's facets rippled. You read your own transfer file. The intake system classified my credentials as non-equivalent. I wanted to know why. Your objection was attached. It was thorough. You cited 6 reasons. And 3 of them were valid. The other 3 were about grip strength, and I've been meaning to talk to you about updating those benchmarks. Kivari stood very still. His facets cycled through several configurations. Then he made a sound the translator didn't render, the Vrelian equivalent of a long, slow exhale, the sound of setting down something heavy you've been carrying since day one. I'll update the benchmarks, Kivari said. He paused at the end of the corridor. Engineer Dallo. Yeah. You were not what we expected. I never am, Nate said. It wasn't a boast. It was the same kind of fact as the torque specification on a bracket bolt, flat, verifiable, and uninterested in how anyone felt about it. He'd been underestimated on construction sites on 3 continents and 2 planets before this one. The sequence was always the same: assignment, dismissal, work, reassessment. The variables changed: the species, the materials, the gravity, the scale, but the arithmetic was constant. You showed up, you did the work spoke for itself, and eventually the people around you stopped arguing with it. The only part that varied was how long the arguing took. The Vrelians had taken 72 days. That was faster than most. Kivari walked away. Nate went back to his tablet and started drawing the vapor barrier fix for level 8. 20 minutes, maybe 25 if he added the drainage slope calculations. The condensation was going to bother him until it was fixed. It always worked like that. You saw the problem, you worked the problem, you moved to the next one. The people watching could laugh or not, object or not, file rebuttals or withdraw them. The work didn't care. The structure didn't care. The structure only cared about standing, and Nate only cared about the structure, and everything else was noise, the kind you listened through, not the kind you listened to. Tesori found him an hour later, still drawing. The theater has cleared. 4 section foremen are waiting outside Drekken's office. They want to know if you can look at their columns. All of them. All of them. And Gorand asked me to tell you the fabrication bay produced a new batch of brackets. He says 2 of them don't feel right. Nate saved his vapor barrier drawing, picked up his socket wrench and stood. Start with the brackets, he said. The columns will still be there tomorrow. Tesori's young, bright facets caught the corridor light. Do you ever stop? Nate considered the question. He'd been asked versions of it before, on different sites, on different planets, by different people who had expected him to quit or slow down or accept the limits they'd assigned him. The answer was always the same, not because he'd practiced it, but because it was true, the way gravity was true. Not a choice, just the way the thing was built. There's always something that needs fixing, he said. Tesori picked up his own data slate, fell into step beside Nate, and together they walked toward the fabrication bay, where 2 brackets that didn't feel right were waiting to be held in hands that would know the difference.